my lovelies, and welcome to the video lesson. Today we're going to be answering the exercise 8 in your textbook on page 114. Let's have a look at our first question. Right, so we're going to start off with A. So they've asked us to draw these 5 different graphs. Sketch the graphs of the following function showing all relevant details. Hey class, phones on silent please. And the way I'm going to answer this question, it's actually this whole question A is all to do with transformations, which unfortunately isn't something we do that much of in this syllabus. And I wish we did. It makes our life actually kind of easy, because many of you may have gone through the whole procedure here. Determine stationary points, points of inflection, x, y intercepts, which is perfect. I'm so happy if that's what you did. But I'm actually going to show you the easier way that we can work around this. And I'm going to start off by drawing a graph that they haven't asked us to draw. All right, I'm going to start off by drawing y is equal to x cubed, right? Y is equal to x cubed passes through the origin. It has one stationary point of inflection. That's what your graph looks like. The first graph that they ask us to draw is y is equal to 2x cubed. So y is equal to 2x cubed is just like the green graph I have on here. It's just a little bit steeper. So it also passes through the origin, but it's just a bit steeper in comparison to y is equal to x cubed. The graph is almost hugging the y-axis. It's moving closer towards the y-axis. So that's the first graph that we're going to draw. And the next one that they wanted us to look at is negative x cubed plus 8. All right, so let's discuss the transformation from y is equal to x cubed to negative x cubed plus 8. So there was a reflection over the y-axis, and the graph shifts 8 units up. So a reflection over the y-axis, so I'm just going to do this as a dotted line. Right, a reflection over the y-axis would look like that. And then I'm going to take this graph and I'm going to shift it 8 units up. So this graph will look like this. Okay, it's going to come up. It's going to pass through. So its stationary point of inflection now will be 0, 8. And then it's going to go down like that. Okay, 0, 8. All right, so for this graph, we can actually also determine an x-intercept as well. But I really think that this question was more about playing around with the transformations. Okay, so I think we're running out of space on that graph, on that Cartesian plane. So let's draw another one now underneath. I think I'm going to rule a line. All right, so we'll pop. How many graphs do you have left? 1, 2, 3. Excellent. That's fine. So we're going to keep referring back to that original y is equal to x cubed graph, okay? Because all of these graphs that we are drawing are just transformations of that y is equal to x cubed. So I'm just trying to get my lines neat and straight. Some OCD setting in. Okay, so y is equal to x cubed, original one. What are we drawing now? X plus 1 all cubed. Okay, so the third graph they want us to draw is x plus 1 cubed. All right, I'm going to add this plus 0, because think back to our previous video where I said that if you have to draw a graph like this, it's almost like a freebie, because the P and Q interact here the same as you would when you are thinking about finding the stationary point of a parabola, right? So we're going to get a coordinate negative 1, 0. So what has happened from the original function, y is equal to x cubed, is you have shifted 1 unit to the left. All right, so that is what your graph would look like. You can obviously determine the y-intercept here. The y-intercept would be 1, right? We let x equal 0. So the y-intercept would be at 1. But yeah, I think what I really want to emphasize in A is about these shifts, right? That's what's important. So question 3 was a shifting of 1 unit left. Remember, if you go left, it's a plus in the bracket, and if you go right, it's a minus. All right, what's our fourth guy? Y is equal to, I'll write it over here. Y is equal to x minus 1 cubed minus 8. All right, so from the original graph, y is equal to x cubed. Describe the transformation. We've shifted 1 unit right and 8 units down. So when it's y is equal to x cubed, right, which passes through the origin like that. So from that stationary point of inflection, shift 1 unit right and 8 units down. Okay, so that coordinate is now going to be down there. So now we can draw that graph. Okay, I'm going to need more space. Oh dear. Get out of your graph. Okay, so this is what the graph will look like. So if we find our x-intercept by letting y equal 0 and y-intercept by letting x equal 0, right, we get a y-intercept of -9, and then we get our stationary point of inflection at 1, -8, and then we go, whoop. I'm not getting that nice, you need almost like that little kink, right, that little dent, so it goes, yeah, that's a bit better. All right, so this was -9. You've got your stationary point of inflection at 1, -8. And if we let y equal 0 to solve for x here. So remember, if you wanted to solve for x, please don't expand this bracket, right? Just pop 8 onto the, put 8 on the left-hand side of your equation, cube root both sides. Right, so then you get that x is equal to 3. Okay, so our x-intercept is 3, 0. How many more graphs do you have to do? 1 more. All right, awesome. I think we're going to have enough space on here. I'm just going to get rid of that. Okay, so the last graph they want us to draw. Okay, there's a little bit more going on here. So graph 5. I think maybe I'll do graph number 5 on its own Cartesian plane. Okay. Just have a look at that. Remember, if I'm moving too fast, just pause the video, compare it to your sketches. These really should look similar in shape. It's just because I'm drawing it freehand, right? But all of these graphs, it's actually that same original graph from before. It's gone. It's lost forever. It's y is equal to x cubed, which I'm actually just shifting up, down, left, right. That's what we're doing. Okay, remember though I said sketches don't need to be works of art. Graph number 5. So I think graph 5 is a bit more going on. So perhaps let's just do some calculations here because we haven't really done any of that yet. Okay, so let's get a nice big Cartesian plane going on here. All right, so they asked us to draw y is equal to -3 x plus 2 cubed minus 3. Okay, so let's just discuss the transformations first from y is equal to x cubed. So I'll pop that on very roughly and quickly. So from y is equal to x cubed, we're now discussing what is the transformation to get here. Okay, so we already know about what these two numbers are doing. -2, 3. Sorry, -2, -3 will be my stationary point of inflection. Right, so this transformation is from the origin, we've shifted 2 units left and 3 units down. So that's going to now be the new coordinate of my stationary point of inflection. The negative here is indicating the reflection over the y-axis, and the 3 is about the steepness of the graph. Okay, so I just wanted to talk us through it first, but now let's actually go about drawing it. Okay, so I'm going to get rid of this. Okie dokes. Okay, so I completely messed up my Cartesian plane. Okay, whatevs, freehand, YOLO. Okay, all right, so I think we want to do a little bit more calculations for this question. Okay, so we've got our stationary points of inflection. To find the x-intercept, we let y equal 0, correct? So I'm going to have 0 is equal to negative 3 x plus 2 cubed minus 3. I'm going to have 3 equals negative 3 x plus 2 cubed. I'm going to divide both sides by negative 3, correct? Yes. Don't worry that it's a negative on the left hand side. Remember that if you can cube a negative, the cube root of negative 1 is just negative 1. It's equal to x plus 2. All right, so x will be equal to negative 3. Okay, so we've got our stationary points of inflection around about there, and we've got an x-intercept now at negative 3. My a value is negative, so it's going to be decreasing, and it's also a reflection of the y-axis. So your graph is going to look like this. Okay, you need to get that little kink going. All right, so the last thing that we just need to do, just let me label these points. So negative 3, 0, that is negative 2, negative 3. I just need to find my y-intercept. So for my y-intercept, I let x equal 0. So it's going to be negative 3 times 0 plus 2 is just 2 cubed minus 3. So that's going to be 2 cubed is 8. So negative 24 minus 3 is negative 27. Okay, so that's going to be my y-intercept. So yeah, this one definitely not drawn to scale, but yeah, we're looking good. Well done. So now we've worked through question A, and those are what your 5 graphs should look like. So let's move on now to question B. So this is a little bit more looking similar to what we've been working on together. All right, so given the function f of x is equal to negative x cubed plus 6x squared minus 12x plus 7, right? First question, calculate the coordinates of the stationary points, write down the coordinates of the point of inflection, sketch the graph, showing all relevant details. Okay, so let's get cracking. So B, here's our function. Remember what I said. So I guess they're not just saying, they've kind of scaffolded this question. So let's just answer it piece by piece. All right, so question 1 says to find the stationary points. So remember, for stationary points, we find the first derivative, negative 3x squared plus 12x minus 12, and we let the first derivative equal 0. I want to look to factorize here, so I'm going to divide through by negative 3. Okay, so this is going to be x plus 2, not x plus 2, x minus 2 all squared, right? So therefore x is equal to 2. All right, so we only have one stationary point, so we know that this is going to be that stationary point of inflection. Okay, let's not get ahead of ourselves. I still need to figure out the y value here. So I sub 2 back into the original equation. So this is where I like just to reach for my calculator, hey. And in place of x, I'll replace it with a 2, and we get an answer of negative 1. All right, so therefore the stationary point of inflection, well, at this stage they're just telling us it's a stationary point, so we figure it out to be 2, negative 1. In the follow-up question, where they do ask us now to determine the point of inflection, I'm already anticipating that this is going to be exactly the same. But let me answer their question. They're giving me 3 marks. I'm happy. So I found the second derivative. You let the second derivative equal 0, and we solve for x. So when we solve for x, look at that. We get that x is 2. We already know that f of 2 is -1. So therefore, my point of inflection is 2, -1, which is the same as my stationary point. Hence the name, stationary point of inflection. They just mushed it together. All right, so we've answered 1, 2. So part 3 in this question, the juicy bit. Okay, so draw this for me now, Claire. So I've got my stationary point of inflection. I still need what? X-intercepts and my y-intercept. I'm so stoked because now I get to factorize a cubic. All right, so for my x-intercept, I let y equal 0. So 0 is equal to -x cubed plus 6x squared minus 12x plus 7. Scooch over. I'm going to multiply through by negative x cubed minus 6x squared plus 12x minus 7. All right, here's our little trick. We list the factors of 7. Hooray, 7 is prime. And now remember, we sub 1 into the, we sub 1 in and we see, do we get 0 out as a solution? We sub -1, 7, -7, right? We sub in until we get 0. So if I subbed in 1, it's going to be 1 minus 6, -5, plus 12 would be 7 minus 7 is 0. Oh, that's awesome. So when x equals 1, I get 0. So therefore, x minus 1 is a factor. Okay. So we know that x times x squared takes you to x cubed. Then we're going -1 times what takes you to -7. So we need a negative times a positive to keep the negative. And obviously 1 times 7 is 7. All right, so now we need to get that middle term. So remember grade 12s, I said you can use whatever tricks or whatever methods you want to do. This is my one. I times these two together. I look at the x squared term in the question. It's -6. So I ask myself, how do I get from -1 to -6? Well, I obviously subtract 5. And that -5 becomes the coefficient of x in the quadratic bracket. Okay, so that's my little trick to get that middle term. All right, so solving for x now. X is 1, or, well, that doesn't factorize. This is another example where our discriminant is negative, so this has non-real roots, so I only have one x-intercept at x is equal to 1. The last thing I need for this guy is my y-intercept. Remember that the y-intercept is just the d value, so y is equal to 7. Okay, awesome. So now I have everything I need to sketch this graph. So I'm just going to scoot everything up. Okay, Cartesian plane. Let's do this. Okay, so A is, what was our A value? Our A value was negative. So we know that the graph is going to start off by, or it's going to be decreasing, right? Okay, so let's draw this guy. Okay. So it's going to be something like, use a different color. Remember, not a work of art. We're going to pass through 7. We're going to pass through 1. We're going to get to the stationary point of inflection. Yeah, okay. So that's at 2, -1. X-intercept was 1. y-intercept was 7. Okay. So yeah, not like a super perfect accurate graph, and what's the word I'm looking for? Yeah, not drawn to scale. But this is really good enough. I'm going to remind you of how to find the x-intercepts using your calculator. Right, so you're going to go mode setup, equation, 4 cubic. All right, so in this question, A is -1, B is 6, C is -12, D is 7. Okay, so there's my 1x intercept, which we determined. Now, some of you are going to be like, what what is happening? Others of you, my AP students, you're going to be like, oh, I know what that is. It's a complex number. A complex number is made up of a real component and an imaginary number. So if I press equals again, it's saying that my third x-intercept is also this thing with the I. So if you see the I, what that means is it was a trinomial which couldn't factorize, and a trinomial which you couldn't sub into the quadratic formula, since you would have a negative discriminant. But you actually can solve for x, but we have to get into the realms of complex numbers, and obviously you don't need to worry about that in your syllabus. So we just get that x is 1, my 1x intercept, and if you use your calculator and you see the I, what that means is that that quadratic bracket that you form does not factorize, and the discriminant is negative. Cool. So remember your calculator work. I don't know. Like I said, I actually just really enjoy factorizing and doing all of this. It's fun. But your calculator, obviously, if you feel like time is an issue for you and the question hasn't explicitly asked you how do you find the x-intercepts, if it just says draw the graph, then obviously you are welcome to use your calculator. Okay, let's do the last question. So question C. All right, so C says that the function g of x is given by x cubed plus 3x squared plus 6x plus 8. Right, show that g has no stationary points. Okay, well, I know I've got to find the first derivative, which is 3x squared plus 6x plus 6. I now have to let the first derivative equal 0. If I divide through by 3, I'm always looking to factorize, always. So we get to this x squared plus 2x plus 2, or I mean, you could have even just looked at that original trinomial. Clearly, this does not factorize, right? So I guess, yeah, you could just say x has no solution. You could also sub into the quadratic formula. You could also go that the discriminant is b squared minus 4ac. So the discriminant is going to be 4 minus 8, which is negative 4. So if the discriminant is negative, there's no real roots. Something along the lines of that. Okay, but it did say show. So you have to do some work, right? You can't just be like, no solution. Okay, substantiate your answer. All right. So like here you could say, since the discriminant is negative, you can't solve for x. Right, question 2. What's up? They want us to determine the point of inflection. Okay, so we need to find the second derivative. So that's going to be 6x plus 6. We've got to let the second derivative equal 0. So negative 6 will be equal to 6x. So x is negative 1. Remember now, we have to sub this back into the original equation. So when I sub negative 1 back into g of x, what are we going to get? So it's going to be negative 1 plus 3, which will be 2, minus 6, which would be negative 4, plus 8, which would be 4. So when x is negative 1, y is 4. Okay, so therefore Negative 1, 4 is my point of inflection. Last question of the exercise. We just like smashed this. All right, question 3, sketch G. So we don't have a stationary point, but we've got our point of inflection. We need to check out any x-intercepts. I'm excited. Why? Because I get to factorize a cubic. So I have 0 is equal to x cubed plus 3x squared plus 6x plus 8. Right? I need to find the factor, right? So we look at our constant, right? Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Eek. If I do 1 isn't going to work. Negative 1 will be negative 1 plus 3. That's going to be, wait, isn't that the same as above? Yeah, we already worked with x is negative 1. So let's jump to 2 and negative 2. I can see that negative 2 will work. If I sub in negative 2, I'm going to get 0 out. So if x equals minus 2 works, then x plus 2 is a factor. Okay, let's get the second bracket going. So the first term will be x squared. The back term will be plus 4. All right, okay, so for the middle term, here's the little trick. So if I times it together, I have 2x squared. My x squared term in the question is 3x squared. So to get from 2 to 3, I'll obviously add 1. So my middle term will just be plus x. So you should be able to see, just by looking at this trinomial, by looking at this quadratic, that x squared plus x plus 4 obviously does not factorize. If I pop it into the quadratic formula, it will give me math error. My discriminant is negative. So I only have one x-intercept at negative 2. My y-intercept is the d value. The d value is 8. Okay, cool. So now I have everything I need to sketch a roof. Okay. So let's just get a nice Cartesian plane. Oh, no, I don't. I want a pen. Okay. Sorry, talking to myself. No worries. Okay. A is positive, so the graph is going to be increasing. It has its point of inflection at negative 1, 4, so it's around about up there. The y-intercept is at negative 2. The x-intercept is negative 2, y is 8. I think I'm going to maybe shift this down a little bit. Okay, so it's going to go like this. All right, so I'm going to label that is what, negative 1, 4. Look, you see my things are really not to scale, hey, but it's fine. It's not a problem. Okay, so, oh, here's this beautiful, I'll try and make it a little bit more neat. Okay, there we go, hooray. Well done, grade 12s, you are so awesome. I hope you found the video useful, and I hope that when you were doing this work on your own, that this is what your graphs look like. So well done everybody, great job, and I'll see you next time. Have a beautiful day.